Hello. Today I'll be speaking about the big benefits of small data. My name is Christopher Lozinski. I live in Katowice, Poland, and you can find these slides at forestwiki.com/slides. So the first question is, what is small data? If you look at Wikipedia and search on small data, they have a great definition. The term big data is about machines and small data is about people, by Alan Bonde. So in this application, every single piece of data was hand curated by a human and is looked at by lots of eyeballs all across the United States. So let's take a look at the application. This is the Green Party Maps application. It's actually multiple applications. What it really is, it's a data model of a large distributed organization. You can see the website at map.howie2020.tech. So what are we going to be talking about today? First, we're going to start about discussing why we use hierarchy for small data. We'll talk about the Green Party Maps application. We're going to drill 7 levels deep into this hierarchy, and you'll just see how natural it is to organize the information as a tree. We'll take a closer look at the hierarchical software model. And then the core of this talk is really about the user's experience with this hierarchical model and some general lessons about small data. And there's some concluding remarks. So let's begin. Why do we use hierarchy for small data? Well, the basic principle in human factors is that there should be no more than about 7 items in a category. That's why we have org charts. That's why we use taxonomies, Library of Congress, Dewey Decimal System. So it's just very natural for humans to organize things as trees. And if you take a look at this largest small data set, small data is often hierarchical. If you take a look at the largest small data set they know of, the awesome lists, here we have the awesome data science list, they're organized as trees. It's just really easy for the users to understand them that way. Okay, so that's why we use trees for humans, for small data. Let's take a look at this Green Party Maps application. We call it a map application. It actually supports multiple applications. And give me a moment while I switch to the web browser. So here you have the United States Green Party map. You can hover over the states and click into the states parties. You can also decide to only show the candidates running for office in this upcoming election, or you can only show the local parties, and pretty soon we'll have an option to only show the elected officials. We can hover over the local parties and click into them. We can hover over the candidates and click into them. And if you scroll down, you see all the contact information for the United States Green Party, a banner for the presidential candidates. And here you have the list of politicians and parties at this level of the map. Okay, so this is organized as a tree. Let's drill down into it. You can think of it as a file system, but really it's running on an object-oriented database. So let's click into California. California is the United States' largest and most technologically advanced Green Party. They decided to show the photos of all of the candidates running for office in California. They also have their own map, and they also have their lists of politicians and parties and contact information. So let's continue to drill down into this map. Here we have Jake Tonkel. Here we have the Green Party of Santa Clara. Jake Tonkel is actually in Santa Clara. Now at this county level, to make it easier for voters, you only see the voters that you can actually vote for. They can also do recommended non-green candidates here if they want to. You can see the contact information, and you can see the lists of politicians, parties. Every page has the Twitter feed for that entity. Clicking into Jake Tonkel, again, his contact information. Now, notice that Jake Tonkel, for his logo, he has placed his photograph here. So this is running on an object-oriented database, persistent Python. It not only supports object class inheritance, it also supports data inheritance. This is called acquisition, very important in small data. So any branch of the tree below him will acquire his image. Very nice. Okay, let's drill into this further. You can see that he has an upcoming event. This is a different content type. It's a virtual meeting. And if you go into the virtual meeting, you can see that there are 2 videos. We can click into one of the videos. So we've just seen two different content types. And you can see that there's not much description about this video. Maybe somebody wants to edit it or add some more information. So this content management system has this very nice WYSIWYG editor. You can do bold, strike through, italic. You can make some things different size headers. Let's see, maybe we just want to make it normal. Make it a different size header. Okay, no, that's good. We can save and view it. And there you have it on the production website. You can see all these things. Oops, we don't want this on the production website. So any good content management system, it's going to have a history view. And we can restore to a previous version. And now when we view it, it's all back to normal. Notice where you're on the tree. These are the breadcrumbs. We'll talk more about this on the slides. But let's go up a level to his virtual meeting. And let's actually take a look at the management view. So it's a tree of objects. You need to manage the different trees. Here's the management view. You can think of this as a file system browser, but remember, this is really a tree of objects, Python objects. And the giveaway is here. It tells you what the class is. These are basic video objects. The other giveaway is here. So here we have the name of the object. That's much like a file system name. It tells you how to get to the object, how to traverse to the object, what the URL is. It goes, this is a slug for the URL. But here we have the name of the object, and we can actually edit that. And so one of the nice things about an object-oriented database is that every entity can have not only a name, but also a title, where the title is what the user sees. The name is what goes in the URL. As you can see here on the left, we can also sort the order of these objects. Can't do that in a file system. And we can select them all. We can rename, cut, rename, retitle, cut, copy, delete. Let's just go ahead and delete it. But again, whoops, I did that on the production website. And there's no history view because those objects are gone. But we do have, this is all running on a transactional database. And so we can just go in and undo that transaction. And now when we go back and reload the page, voila, everything is back to normal. So, okay. Let's go back up to Jake Tonkel. We'll view him. And let's just take a look at his contact information. So remember, this is a tree. Come on. Here's the contact information. You can see the Twitter account, the contact information for Jake Tonkel, for the Green Party of California, for the whole Green Party map and directory. So it's organized as a hierarchy, and contact information should be hierarchical also. Okay, back up to the national map. A whole bunch of features for managing them. We'll take a look at one of them, which is the progress. So we have a large number of people entering data. Here in the progress view, we can see who edited and entered data most recently, who added data or who edited it, and we can click into the particular page. Let's go back. Also, you can add, there's a whole bunch of different content types that the users can add. And if we actually look, one of them is a link. And so here we have a whole page of links on defund the police. So one link doesn't amount to much, but if you have a large number of links into the internet, it gets to be very interesting and useful. Here we have a list of literally hundreds of links related to climate change. Very hard to find this information. And I'll show you two more things. Here's the newest item view. So any branch of the tree, you can see what the newest items are on that branch of the tree. So it becomes a news site for Green Party organizations. And finally, I'll show you a website we put up for Howie Hawkins. We'll come back to that in a minute. Okay, so now let's switch back to the presentation. So you saw that this actually supported multiple applications. We have the Maps application. We have a directory of all the organizations in California in the United States Green Party. We have this, we saw the Howie Hawkins, that was what we call an instant backup website. There was the news sites. You can see in Santa Clara the recommended voting lists. and there's content management system, and there's also Discord bot I didn't show you. So it's a rich application, all based on this data model of the United States Green Party. Now that you understand the application, let's take a closer look at the hierarchical model. These ideas, a lot of these ideas come from the Plone community. So the first idea is traversal. We have a tree of objects. We have to find the object we're interested in. So we start at the root. The path for that and the URL is just slash. We traverse to /map, /map/California, /map/California Santa Clara. Okay, this is the object we might be interested in, the Santa Clara. But the problem is, in any real hierarchy, the organization is changing, things are moving around. And if you have a path-based URL, then after a while, that URL will no longer be valid. So what we need to do is we need to use something called canonical URLs. So in a canonical URL, every node on the tree has a unique name, its canonical name. So here we have slash, we could have also called it root. Here we have map. And then here, you don't have to traverse to it. You can just access it directly as California, or you can access this one directly as Santa Clara, which means there are two paths. There's both the traversal path and there's the canonical path to any object on the tree. And that's why this is an object-oriented database. The end user doesn't see it. It's really transparent and easy for them, but it has all the functionality that's needed. And then once we find the object, we need to look at the views on the object. So all of these objects support multiple views. Here is the map view. Remember, we have there's the edit view. Here's the news view, the most recent items. And here's the management view, which shows the most recent adds and edits. If we keep going down, here are the menu options. There are a whole bunch of commands we can execute on these. There's a whole bunch of content we can add to any node on the tree. So there are lots of different views on the object as a core part of this approach. It comes from Pyramid, actually, these ideas. Let's take a closer look at the hierarchical model. In the first row, we have the root. In the second row, we have the Green Party of the United States. In the third row, we have the state parties. And then in the fourth row, we have local parties. So at the second level, at the Green Party of the United States, we put the presidential and the VP candidates. That's because anybody in the whole tree can vote for them. At the third level in the state party, we put the governors and senators. That's because anybody in that state can vote for them. And then the local party or county level, you can have all the other candidates. And there's actually one more level in this hierarchy, which is all the other websites. So here we have what I call the contact information for Jake Tonkel, but it actually has links to multiple different websites. His web page, his Twitter account, his Facebook page, maybe his Facebook group, Instagram. Also on the page, you'll see for the donations page and his events page. So the information on the internet is distributed, and a good directory needs to index to all of those different sites. Okay, now remember I showed you the Howie Hawkins page, but I didn't talk about it much. On the left-hand side, you can see the tree, and you can take any branch of the tree and cut it off and use that to create a separate website. So what we did, that wasn't really a separate website for the Howie Hawkins page. It was just part of this main website, but just under a different domain name, we only show that branch of the tree. We hide the rest of the tree. So that gives you very nice, easy to use instant websites. Particularly as a new candidate wants to run for office, it just takes us a few minutes to create an instant website for him. Reduces the barrier to entry. And this all looks really simple, but there's a lot more complexity under the hood. So let's take a look at the different content types. This first column, we're going to look at sort of the basic content types, what you'd expect in any content management system. So the WYSIWYG page, we saw the editor for that. For the data scientist, you can also use a markdown page. We saw the defund the police page with the link content types. We saw a YouTube video. We saw an online event. We didn't see an online organization. We did see logos. Remember, there's data inheritance of logos. And we did see banners. We didn't see a file. Then the Forest Map Wiki has a whole bunch of types related to maps. So Google Maps, OpenStreetMaps, GeoJSON maps. those are the state maps where you can click on each state. So you need the GeoJSON data to outline each state. Organization objects are local parties. Politicians are candidates currently. Soon they'll be elected politicians as well. And then map organizations are things like the national map, which is the United States Green Party, or state green parties with maps. The other thing you want to do is you want to make it easy for multiple end users to update the look and feel in the browser. So this has a whole bunch of templating tools in the browser, both the basic ones like HTML, WYSIWYG HTML, ACE HTML, Secure HTML for reports. But remember, this isn't a file system. This is an object-oriented database. So instead of just having a CSS object, we have CSS and CSS folders make a tree of CSS objects. JavaScript and JavaScript folders make a tree of JavaScript objects. And B-tree images and their thumbnails make a tree of images. And then we'll also talk briefly about Pug, and I've done a lot of stuff with Python in the browser, if anyone's interested. Okay, so let's take a closer look at these B-tree images. Here we have on social media, you need a little image. And so here we have /social media image. It's the United States map. But also we use this in various thumbnails across the site. And look, I'm not a graphics artist. I don't know how wide a thumbnail should be. So I tried different things, but to generate all the thumbnails manually for all the different sites, way too painful. So what we do is under the image, we store, underneath the image, as its children, we store the different thumbnails. This one for 400 pixels wide, 200 pixels wide, 100 pixels wide. And then to access it, I just access /social media /200 wide, whatever the pixel width is. And it gives me that thumbnail. And if that thumbnail doesn't already exist, it generates it for me automatically with a security feature. So really nice what you can do with an object-oriented database. I should also mention Pug templating, great for managing hierarchy. HTML is actually a tree, okay? And so the Pug is the leading templating engine in the Node community. Also comes from Haml and the Ruby on Rails community. There's also Pug for Python. On the left-hand side, you can see a very simple Pug template. You can see it's just like Python. It uses indentation to tell you where you are in the tree, in the structure. And on the right, you can see the HTML that it generates. So very nice tool. And Pug is particularly important for managing Bootstrap menus. Bootstrap menus, if you look at the HTML, it's incredibly complex. It's very confusing. So I do all the menus in Pug, much, much easier in the browser. Also, big hats off to JSON schema. So we have 5 different columns. On the left-hand column, number 1, you create a JSON schema. And then on the client in column 2, we use that JSON schema both to create a form, and very rich, complicated forms, in very interesting forms, both to create the form and also to validate the data on the client. And that way the user gets instant feedback. We then take it, we generate the JSON from that, we submit that to the server, and then on column 4, we validate that on the server. And then on column 5, we update the database. So JSON schema, very powerful. I'm actually planning on offering courses on JSON schema. I really love it. Okay, so let me bring you back to the video page we were looking at, and for Jake for District 6. And in the upper left-hand corner, we can see what are the breadcrumbs. Let's zoom into those. And what the breadcrumbs do is they tell you where you are in the tree. So on the right-hand column, we're going to do a simple calculation of how big the tree is at that level. I'm not going to focus in on it. You can watch it if you want. But basically, you end up with about 7 categories in every level of the tree. At the map level, we have 50 states. Okay, so that's an exception for 2-dimensional images. And then below that, we have Green Party of California, Green Party of Santa Clara, Jake Tonkel, Team Tonkel, Educational Equity Video. So just saying on average, we have 7 items in every level of the tree. If you go this level deep in a tree, you can have like 5 million items. So you can manage a huge amount of complexity. And yet because it's a hierarchy, the user doesn't get confused. He knows where he is. Of course, if you have such a large system, you have to make sure that people don't step on each other's toes. So you need a good security model, and the Forest Wiki has a hierarchical security model. So on any branch of the tree, if you have editor permission, you can grant editor permission to people on your level or below your level. So the national group can grant it to California, can grant it to Santa Clara, can grant it to Jake Tonko, can grant it to whoever helps. So for a large distributed organization, hierarchical security model works really nicely. Okay, that's the end of the discussion about the hierarchical model. Let's take a look at the user experience. This is really the most important part of the talk. Small data is hand curated. Okay, so here's our data curation team, 18 people. We have a Basecamp discussion group on the Howie Hawkins campaign Basecamp server. And every piece of data was hand curated. And even when we crawled it, when we could, the data that we crawled either had been hand curated or we needed to do additional curation on it. So a lot of manual work here. And the users find that it's very useful. It has the links to all of the relevant websites. And so it's just great. You instantly find what you need. And really, it's more than useful, it's loved. I asked my boss what he thought about the project. He said he's just ecstatic. Holly Hart, the Green Party CCC co-chair, they're the coordinated campaign committee. They're responsible for helping candidates get elected. She said the CCC really likes this, and lots of other people really love what we're doing. And people are upset if we get it wrong. So in the United States, it's possible for someone to register as a candidate, as a Green Party candidate, even if he's not endorsed by the local Green Party. So we got a call from one state party saying, we do not endorse this candidate. What are they doing on the website? Boy, were they upset. Okay, no problem. So we deleted that person. That person, when they found out they were deleted, oh boy, they were even more upset. So people really do care about this data. Of course, the small data has its problems. Its Achilles heel is that it's labor intensive. So we needed a lot of volunteers to do this. The volunteers worked really hard for a long period of time. Either that or you're going to generate a lot of good jobs for people. Lots of people need jobs, so good thing to do. And when you have all these people working on it, you have to manage the process. So the project manager, Alex, he created a list in Basecamp of all of the different states. And as each state was completed, he would mark it completed. He'd do some quality control on it. When a problem occurred with a state, when somebody reported a problem with a state, the appropriate person for that state would be notified and the data would get updated. So you have to manage it. And then you also have to sort of manage it more real time at the more detailed level. And so here we saw the view where you could see which pages had been added or edited most recent. You can click into them. You can also sort of audit to make sure that people beneath you aren't adding spam to the website. Okay, so that's about the people. Let's talk about the data itself and about the whole small data. So small data is low noise. First of all, it was hand curated. Secondly, if there are ever any problems, the users give a lot of feedback, so the data gets corrected very quickly. And then third, if you're a state Green Party, instead of linking to the national map, you can link to the state map. And so that has an even better signal to noise ratio. And remember, on the national map, we showed you that you can either show just candidates or just local parties, and soon just politicians. And so that also reduces the noise. Or you can, that same software works on the state parties. So you can just show in the upper right-hand corner, you can just show the politicians, the candidates for office in New York. So small data is very low noise. And it's really small. Many people in the audience may not even recognize this. This is Floptical, came out in 1988. Not counting the image, you could fit all the data on a Floptical, actually half a Floptical. So it's very small data. And because it's so small, it's really fast. For those who aren't from the United States, this is Roadrunner, old cartoon series, who it was always much faster. Wile E. Coyote could never catch Roadrunner. And because it's small, everything can be cached in memory. Maybe it takes a moment or two for the database to start up, but after that, everything is cached in memory. And also there's the web server for the anonymous user will cache the pages so that everything can run really quickly. And also requires a very small server. So typically we run these either on DigitalOcean, or I really like Linode with their daily backups. We run this on 4 GB server. It's a virtual private server, just a fraction of a whole computer. It costs about $20 a month. After the elections, we could probably, and for sure we can shrink it down to a $5 a month server. A gigabyte should be plenty. And the reason this is important is because small data consumes much less energy than big data. It's not just the polar bears are hurting, right? Climate change is happening, the world is heating up. We all need to consume as little energy as possible. It's great that we have online meetups. We're not flying as much. I see different numbers about how much energy the internet consumes. If anybody has the correct number, I'd love to hear it. I suspect that many of these internet giants don't want to publish how much energy they consume on their server farms. But I see numbers from 2 to 10%. Who knows what exactly, but whatever it is, we need to reduce energy consumption globally. And of course, once you're being efficient, it just makes sense to have small code as well. So not counting a large number of third-party libraries, there are only 12K lines of Python code. So that massive code reuse. And because of that, the small project only needed one developer. There's also a system admin. That wasn't as difficult. But you only need one developer. And remember, it's not just one application. It's a large number of applications, and new applications are rolling out faster and faster. So I'm really proud of how much the small data project accomplished. Okay, a couple of concluding remarks. This is a data science conference. There wasn't that much data science in this application. We did do the maps. I know my boss goes over the maps with a fine-tooth comb. I don't exactly know why. I know his boss, he's the co-chairman of Illinois, and he said he never really understood the Green Party of Illinois until he really worked with the data on the maps. And now he understands better the whole state party. And on the right-hand side, we did a very simple calculation on how many candidates and how many local parties are in each state to find the most active states. We added them together. Really, we should have normalized by population. Okay, when do you want to use small data? Well, during global warming, wherever possible, you'd like to use small data instead of big data. And right now, the world is experiencing global warming. It works very well on a niche topic. If you're indexing the entire web, well, that's going to be an awful lot of labor. But if you're just doing the US Green Party, soon the global Green Parties, that works. All of the awesome lists are each is indexing a niche topic, and they're all indexing the web as the other time to use small data. The web has so many pages, effectively it's a high on any topic. The web has so many pages on any topic, it's effectively a high noise environment. So in high noise, when you need human curation, small data is a good idea. If machine learning doesn't work for you, small data is a good idea. And if you want to, and really what it does, it gives you a better user experience, is the really big benefit of using a small data approach. Software tools, let's see how much time I have left, only a minute or two. I'll just speak about the storage. So initially we all do our development on the file system, but increasingly I'm doing development on an object database. Files don't have children. You can't do the images with B-tree. You can't do the B-tree images with thumbnails underneath it. And directories, they don't have attributes, they don't have methods, and you can't send a message to a directory. So I really like working on an object database. And remember, a file system, the file system first came out in 1965 in Multics. I actually used Multics in my first software job, second software job. And so the world really needs to move on to something more modern. So lots of other questions, if you have questions about the other tools, you can ask them later. And then links, maps.howie2020.tech, forestwiki.com/slides, and pythonlinks.info/contact. Thank you very much.